So, hello everyone. This is like week 4, and today we'll be learning about integrals. We can get interrupted in between probably because there's a class here, but we'll continue then. Okay. So, I'll just share my screen. So, you all know me. I'm Jagriti. I'm a fourth year PhD student at IIT Gandhinagar, and I'm working with Professor Carla and Medical Ultrasound Engineering Lab. So today we'll be looking at some integration rules, laws, and if you get a derivative, you know the slope, then how can you calculate its integral and vice versa. Okay, so I hope my screen is visible to all of you. I'll connect, let's wait. I'll just connect with my tablet also. So that we can write. Okay, there we go. Mm, okay. So I like to ask you all, were you able to find this particular book reference like from the PDF of this book? If not, then you can always it's like I myself didn't find it because it's there in my institute library, but online PDF I cannot find, so I cannot share it with you people. But one thing you can do is like you can look for the you can ask in the discussion forum. So I hope you all know where to connect for discussion forum. It's there in your online website only, and right tab you'll see that's for discussion. So if you go there, you can enter any sort of queries if you have for the assignment, or if your marking wasn't done properly. Those things also you can add in there. Okay, so those all things you can check from there, and you can also address your comments to TAs. Like if you want someone else specifically to reply, you can comment it, or also you can add not add, but you can give a reference that okay, I need it's like from something from advisor if you want. So NPTEL often conducts this online session by the advisor and himself, the instructor of the course. So since this course is like 8 weeks, so probably, and this is fourth week, so we are like almost way through, way half. So the meeting with an instructor will probably happen soon, and you'll also get an notice about it that when the meeting is going to happen. Okay, so that was the book. I'll just join quickly. Okay, so we are here. So first I'll just show you through the slides and we'll guide you that how it is. Then we'll go into writing that how it actually comes. So last time we saw this derivative and we saw that how smaller the range you can make it to this accurate and the precise curve, the slope that you get from there. So this is like change in the y function versus change in the x function. Okay, and that's how you calculate dy by dx. So here, sorry, these things are visible. Probably I can just present it. It's fine. So limits goes as x plus h minus f of x by h. And then similarly, if you make it x tends to a. So the goal is like you make both terms 0 by 0. So as near as possible. I hope you all remember the L'Hopital's rule that we saw. Similar to it. And then there were this rule. So I'm just going again and again through the rules so that you can revise them again and again. So by now you all know that for constant it's 0, and for a variable that's a function of x, adjust the variable. There are power rule like which states that n x n minus 1. We have derived this, and in the recorded lectures also the instructor has derived this, that how it comes from the graphs and one by one. How near you go, the slope also increases. The accuracy of the slope and the values that you achieve is also higher. Here also, now you see that if it's a byproduct of two terms, you have the first term, then derivative, then this second term derivative. For denominator, the quotient rule, we saw that you can solve it two ways. One is like you take it like product of u times 1 by v, or else you know this formula and solve it by this. Uh, these things follow additivity and additivity linearity principle. So you can directly add them, you can subtract them, you can separate them. Okay. you have a chain rule, like as long as the function is not in the state of, or it's not a function of x, till then you need to derive it again and again so that you come to that point. Now we'll see about what are integrals. So here I'm just introducing to you about them, and then we'll see. So like I wanted to write this, but it's fine now since we are here. So if one can go from x square to 2x from derivation, he or she can also go from a 2x to x square using integrals. So that's like both two-way process. If you have derivatives in one-way process, the second-way process is integration. For integration, there are two integrals. One is indefinite and definite. So for derivations, we never had some limits through which we had to evaluate it. We just derived the term for which we have. So it was like always a function of the variable that we are differentiating it with respect to. Okay. Now, for integrals, it's always within the limits that you're looking at. If you have no limit specified there, then you'll always end up with a constant value, and that constant would be an initial value. But if it's a definite integral, then you'll have two limits against it. So the function is evaluated within those two limits. So here is an example. So I just took pictures from Google Images here. So you all can always find these images there. So in my Excel sheet, you can get the course slide attachments that are there here. So no need to take screenshots or to record the lecture. You can always go and find the material there in the Drive folder. The link is attached in the Excel sheet that you get in the record a live session once. Okay. So this is how you do an indefinite integral. Well, you don't have any limit specified next to it, whereas a definite one is like within two bounds and limits that you're specifying for the curve. Okay. Now, if you have to evaluate a limit, you like, let's say if whether it's definite or indefinite for this particular curve, you won't be able to always integration is also called as equivalent to area under the curve process. Okay, so when it's in between two limits, you can always subdivide that limit into multiple degrees, so multiple sections or parts. So here you see there are multiple parts of it, f1, f2, f3, and n number of parts of it. So you have an area under the curve as like you can mm, additively add those different sections and have a limit accordingly. Okay, so there are certain rules for this definite integrals and indefinite integrals. We'll first go through definite and then we'll go through examples. So through the course session, I hope that you all know till now that what are these. So the first one that you see here, I'll just present my screen. That you see over here is order of integration. So yeah, if so here, whenever you evaluate this one function, let me have my pointer. Yeah, when you evaluate this particular function, it can be written as f of a minus f of b. So it's always upper limit minus lower limit. Now, if you change the limit, the minus sign goes out. So how will you do? So if this is the first LHS is f of a minus f of b, you take minus outside, it is minus of f of b minus f of b, f of a. So this term is nothing but negation of it. Okay. Then if you're evaluating at two same intervals, so it's like f of a minus f of a, that's 0. Of course, you'll have a constant term there, but evaluating within two exact same limits will give you 0 because you're not integrating it at all. Okay, then you have constant multiple. So if you're multiplying it by a constant, that constant is not function of a variable that you're integrating it with. So that will come outside. Similarly, if you have a negative sign with it, that will also come outside. It's not function of the variable that you're integrating. So that will come outside. Everything which is not a function of x, that will, or the function that you're integrating your term with, the function with, it will directly come out. And if you have, let's say, a to b f of x, I hope I'm audible and my mic is on. 2 minutes. Yeah, yes, my mic is on. I don't see anyone join. Let me give an access to people in case they join. Okay, there's no one, so it's not even asking me to give an access, but it's fine. We'll see. I'll get a notification if someone joins. Yeah, and this also follows principle of linearity. So if you have like terms added together, you can separate them, but remember that the sign will always remain the same. You won't be able to change the signs there. Of course, if you change the limits, you'll be able to change the signs there. Follows principle of additivity. If you have like terms from A to B, B to C, it can be directly written as A to C because just now we saw that you can add them all together. So it follows principle of additivity here. Okay. Now there are these rules of integration. I know it's a lot. This is for indefinite integrals. Now if you want, you'll be solving multiple examples, and till now you are like limited till this sine and cos. So these two terms you are limited till. So you have been doing 1x, that's x plus c, then a dx, that's ax plus c, x raised to n. So take some time to digest this, like sine x and cos x. In the online lecture, professor has already given derivations for it. We'll also do one such of it and few examples, and this ones too. So from here, it just all trigonometric identities. You won't be able to solve them unless and until you don't know them. So I'll tell you that first go through trigonometric identities, the functions and formulas, and then only look at these, or else it would be just you memorizing these terms. Okay, you can have a look. I'll just come. Yes. So with that, the slides are done. I wanted to add this rule so that you can always go back and look at the formulas. You'll always get the sheets like this online. So it was the motivation for adding these things was just that you know that there are enough stuff and material out there. You always don't just need to focus on things that are just here and what we teach. So you can always go and look because these things are like pretty well established. So you can always go and have an idea that how get formula sheets there. Okay. So starting with, we'll see at some examples. Mm, okay. So till now you know that how do we find we if we know, so okay, how to find the function if we don't know the slope of it, right? So here we are nothing but if we know the function, we derive it, and this derivation gives us the slope of it, right? So this is the slope. Now if you go other way around, that's integration. Now, when you do this integration, you'll get the other terms. So there are like few examples that professor also gave in his lecture. That one such example of actin and myosin. So the process of polymerization, right? So there are two processes. One is polymerization, one is depolymerization. So if you have a the rate at which the length of the actin changes, if you have one as polymerization rate and one as the other one depolymerization rate, the length of it will change. The length of it changes over time. So you have dl by dt, and that's function of time, right? So you can write this dl by dt as changes in this rate. So we always know that the increasing one is the highest, so we have it at first and minus the decreasing one. Now if you do something as dl can be equal to kp minus kt times d, and now what you can do is like integrate both sides. So this sign is nothing but this sign is for integration. Okay, now into if you integrate it, now keep in mind that this is indefinite integral. You don't have any particular limits next to it. Okay. So this dl will become L, and this will, so it's a constant. So you can take it outside and do it for dt. Now dt will give you t, right? So this will give you t, and then you'll always also get the c term. This c is a constant because you're not evaluating it within any limit. So you'll always get a constant value. Now, if we want to add a C, now this L is also function of time, right? Because we evaluate it with respect to time. Now, if you want to see, wait, sorry, we can always have a t equals to 0, evaluate it, L of 0, this becomes 0 and plus c. So the c is nothing but your initial length of your fiber that you're looking at. Okay, so that's how you get it. So now if you want to evaluate it in between two times, let's say if you know the delta t here, from delta t, you'll get that in between what time intervals. From there, you can get an exact value of c where you are looking at. Okay. Let's just do one more example of our slope. Okay, so we have dy by dx is m, right? Now if I do dy is equals to m times dx, integrate both sides. So I get y is equals to m times integrate of dx. I get y, so tends to m x and plus c, where c is nothing but y of 0. Now this c is often called as initial boundary condition. Okay, which tells you about the initial state of the system that you're looking at. Now there were rules of integration that we already looked, so let's just directly start from few examples. That is like I showed you the rules there, but if we just do it on ourselves, it's uh, like more intuitive to see. So if you have y equals to x cube, okay. Now what would be the derivative of this? This would be like this. 3x square, that you know it comes from this nx n minus 1 from the power rule, right? Now if this comes from the power rule, now you might want to integrate it. Let's say dy is equals to 3x square times dx. Now you integrated both sides. Now when we integrated both sides, you get dy as y, and then you get a 3 constant, then you have x square, and then you have a dx here. Now you have 3 integrated. So what is, now we just looked at the property here. What was that property? Property of x raised to n integration is with respect to a function dx is equals to x n minus n plus 1 by n plus 1. And for differentiation, we saw that everything came up to the front. Here, everything goes down to the denominator. Okay, so this is how you evaluated the function. So you'll have x raised to 2 plus 1 by 2 plus 1, that's 3. Okay, and again, since this is indefinite, you'll have a c there. So you added a c there. So you get something as 3x cube by 3 plus c. You eventually get x cube plus c, and c is nothing but y of 0. If you have initial condition as 0, you'll directly be able to map to the original condition that we looked at, started from. So both are same. So okay, so now you know the rule of this. So that's also a power rule here. Okay. Now going with that, if we do for let's say e raised to x. Now you know for e raised to x, it goes as 1 plus x by x square by 2 factorial. And when we did our derivations, we saw that differentiation of e raised to x is e raised to x, right? Because this would be 0, then 1, then again 2x by 2 factorial, that same. So the series repeats, but just after one term. So you only don't have that one term. So this we can directly write it as dy by dx given my y is equals to e raised to x is also equals to e raised to x is also equals to this particular series that I have over here. Okay. Instead of writing again, let's copy paste it. Okay, there you go. Now, if you want to integrate it, okay, so how will you do? Integrate, oh, sorry, integrate. Okay, and of course, with dx and all with dx plus and dot dot dot, and then this is also dx, this is also dx here, right? So dx in the numerator, of course. Dx cancels, you have y, and this is equals to integral of e raised to ex dx is equals to. Now we saw that it is linear, so it is additive. You can separate all terms out. So it will be integral of 1 dx, integral of x dx, x square, x cube, and all, and so on. So now you get x 1 times dx, you get a x, then you get something as x square by 2. Then you get something as x cube, so by 2 factorial. Then you get x cube by 3 factorial. Then you get x power 4 by 4 factorial, right? Now this thing repeats, but now you have an x here, right? So plus c. So this is how you integrate it. Again, similarly, if you do for y is equals to cos x, okay? So now for cos x, the series is 1 minus x square, correct me if I'm wrong here, plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus and so on. Okay. Now if you want to look at the derivative of it is equals to, oh, Not the derivative. We want to integrate it, but okay, let's just first look at the derivative. Okay, so this first term is 0, right? This is 0. Then you have a minus sign. Then you have 2x by 2. Plus you have 4x cube by 4 factorial. So 4 times 3 factorial, we can write it, right? It's n minus 1 factorial, n factorial. Then minus, you can write 6x raised to 5 by 6 times 5 factorial. You can write it this way, and plus and so on. Now, if you take a minus sign out, you have a x. You have something else here. If you take minus sign out, you have x. Then this minus will go as minus, because minus minus is plus. Okay, and then this comes as x cubed by 3 factorial, and then this comes as plus because you want a minus here. This is x raised to 5 by 5 factorial, minus and so on. Okay, it will continue. So what do you see? This is something for sine. So this is minus sine x, right? Minus sine x is what you get for differentiation. Now if we want to integrate this again, integrate the one that we just wrote. Okay, so negative sine x, we will want to integrate it. This one particular series that we had. Now when we are integrating, now we know that keep the minus sign outside. When we are integrating this term, okay, so when we are integrating this one, x would become what? X raised to n plus 1 by n plus 1, right? So this would be x square by what? 2, right? Huh. Then this would be minus x raised to 4 by 1, 4 would be added. So this becomes 4 factorial. Then this would be like x power 6 by 6 factorial and minus and so on, whatever continues. Now, before writing that, in this particular cos x series, we have a 1 function there. So how do we bring it back? There was a trick to do it. Like if you have a 1 there, you always bring the 1 to another side of the series. Something like that. If you have 1 plus cos x, no, 1 minus cos x is equals to this. And what is this equal to? If you are integrating it, cos x should return you sin x. So the inside one, and again, this one should give you something as cos x. Yes. Okay. Now you see here. So for this one, if you take, this is equals to y is equals to cos x is equals to 1 minus x square by 2 factorial. Okay. Plus x raised to 4 by 4 factorial minus x raised to 6. Now, what do you see similarity in between these two equations? Now, let's say this is my equation 1 and this is my equation 2. Now, if I take this equation, if I take cos x to the other hand side and this all terms to other hand side, this will become all, sorry, what did I just say? Yes. So if I take minus plus 1 this side, minus 1 this side, take this 1 in towards this side is equals to, take a minus sign outside and you have x square by 2 factorial minus x raised to 4 by 4 factorial plus x raised to 6 because you want a minus sign and minus and so on. Okay, you can write it this way. Now, do you see similarities in between this and this? So you have something as, are we writing it correctly? Let's just see. Okay, so you have this term. I thought I was able to figure it out, but let's say minus of, no. This entire minus term can be written as cos x minus 1. But you do have a extra minus 1 here. Oh, and then this is definite integral, right? And then when you integrate it, you get a c with it, right? Now, when you want to evaluate that at x equals to 0, y of 0 is cos of 0. So this is 1, which is equals to your c, right? Oh, sorry. Cos 0 minus 1. That c is 0. Cos 0 minus 1. Sorry. That c is at initial condition, not this one. Yeah. So this is 1. So initial condition of the function, evaluate the function at 0. Okay. So this gives you 1. So the C is 1. So you get cos x. There was a long time I did this. Minus 1 plus 1. So you get cos x here. Okay. So I hope this is clear. So that is how your one more homework that you can also do. You can go ahead and try it for y is equals to sin x. You can try this for homework. Okay, how to integrate it. Nevertheless, if it's like just if you solve it this way, always you'll remember what are the terms next to it. If you don't solve, then if you just try and memorize it, then it would be too hard for you to difficult to remember, right? And then we just saw that if you have a function, you can do graphical understand graphs to understand. You can use them directly. Let's say I have a function like this and I want to evaluate it in between these limits. Now I can take parts and chunks of it, like sum them all through these limits, as how we just saw before. Okay, so I can have like this from 0 to x and this is from y. Now I can sum them all for different x. So for I, and I can give for xi, and let's say I have a function which is function of I. So I can just add it here. So this, sorry, will just give me an approximation of the area under the curve which is under this. So professor gave an idea that okay, let's say if you have 0 to 1 here and this is 2, so this is nothing but multiply all with each other. So this is 0 times 0 to 1 is nothing 1 minus 0, and then you multiply it with 2 minus 0, so you have like 2, right? So that's the area under the curve that you get. Okay, so this is what you get from there. So if we get a similar example, if you have to solve like m is equals to dy by dx, and that is equals to, let's say, 3x. Okay, so now let's solve 3x dx. Let's say if the limit are like 0 to 10. So you'll have keep 3 outside, integrate x dx. So better you write all steps, because if not for this NPTEL course, even if you do for your college exams or school exams, this is like each step gets a point. So and then from each step you know where you're trying to make a problem there, so you know there. Okay, if you, in case you make mistakes. Okay, and then you have 3 times you have 10 square, that's 100, minus 0 when you had a 2 here, so this is like 50, and then you have 150. Okay, so that's how you for solve for definite integrals. One more example that I like to tell you is like, now just now we saw something as this was definite and it had no sign there. But what if a case that I have something as, okay, okay, how I've drawn makes it look that it's not same, but let's just condition this and this, okay, all in the same. So now I want to evaluate my area within this particular curves. Now area within those curves is I'll have to integrate them, and integrate them is like those are, it seems to be as a rectangle, or sorry, not rectangle, but triangle. It would something as half base height. But now you look here, this is 0 to 1, this is minus 1 to 0. Both are symmetric. Sorry, you have something here? Ah, sure. Okay. So if, sorry, I'll just close the door. Yes, so if these two are symmetric, given they have equal area, you know that, and again, these are signed. These are like keywords for this, and this is negative and this is positive. Of course, they'll both cancel out and you get a zero area under the curve here. Okay, that's zero there. Similarly, if you have a function as this, okay, if you have a function like this, now you know for this one, and this one. So which function is this, by the way? This is y is equals to sin x. right? Now this is from 0 to pi and then pi to 2 pi. You see that it's equal in area. Let's say amplitude is also same because we know sine oscillates in between 1 and -1. So this area under the curve is also 0 because both are equal. But now if there's a case such as cos x, this, then you have something here, right? So you want to evaluate an area under the curve for this cos x, right? So for this whole chunk, you'll get a -1, but this chunk you probably will get a half. You'll have to evaluate it. So this area you'll get something. You'll get a positive term there. If we just look at random numbers, can be half also. Okay, so it won't be. Now, this thing works if you have odd functions. ODD, okay. What are odd functions? These are functions where there's a sign, where the function doesn't return you a similar, they aren't the same, will give you a negative sign outside. Whereas if you have even function as cos or x square, as cos x or x square, you get y of x is equals to y of minus x. So get a same function there. So you won't be able to, okay? Now we'll look at a whole new different thing, and that was also not in the formula sheet that I gave you, is something as, and this is the last part of it, and after that we'll do the assignment. So this is product of terms. Okay, so we'll look at integration of product of two terms. Now, how do we do that? So if you have a function and you evaluate the function as uv, okay, now let's say this u of x is some x, this v of x is some e raised to kx. Okay, and now you want to differentiate it. So the formula, okay, we first differentiate this term as df of x is equals to how you go in differentiation. Okay, it would be similar here. So you are differentiating it now essentially. U and then you have dv by dx plus we have b and then you have du by dx. Now you are integrating it. Now whenever you're trying to integrate it, we'll see that let's also attach some limits to it. Okay, within certain limits. And of course, all of them has a term of dx here, dx here, and or dx here. Okay, now let's just take this term outside and this minus term inside. So you have like a times b and you have u dv by dx times dx is equals to, now this keeps here, whereas the other one comes the other round, df by dx times dx minus, you have a to b, v du by dx times dx. Okay, so you have something like this here. When you have terms like this is essentially you're just evaluating your own function with respect to the intervals that you have, minus you are evaluating the derivative of another function. So I'll show you how it goes. Don't just say that, okay, we are essentially adding the function and its own limit. So we'll just take one example that the prof also took. That example was derivation of a, no, not a, but 0 to infinity for e raised to, sorry, for x e raised to minus kx times dx. Now let's see. Let's keep our u of x as x and this dv by dx, what you have in the LHS here. So this was your whole formula, okay, that we just derived here. Not derivation, but we just took terms from LHS and RHS. So that's your formula. And then your dv by dx as e raised to minus kx. Okay. Now, previously, you know that if you do dv is equals to e raised to minus x kx times dx, you want to integrate both of the terms, dv will become v, and then this e raised to x. So if you have something as e raised to x, that x would again be evaluated. That's chain rule. Initially for chain rule, for derivation, you add it in the numerator. Now you add in the denominator. Okay, so if you go this way, minus kx, and it has a sign. So that is minus k, and then you have a c here. Okay. Uh, That's it for derivation for this one. And now, okay, now since you had limits for this one, you don't need to add a C here. In this case, it's fine. Now, probably if it's just justified, then it also works. Okay, now we want to evaluate the function at. How will you write? So this is written as this. Now you evaluate the function itself. So this is your function. Okay, now you need the function that's u and v. So this was your v. So you have u and times v. That's e raised to minus kx by minus k. And you evaluate it in between 0 and infinity minus you integrate 0 to infinity, take your v e raised to minus kx by minus k, and then differentiate x. So this is 1 and times dx. Okay. Now what this gives you? Now see, e raised to minus infinity is 0, whereas x is 0, whereas this is 0. Everything will give you 0 in this case. So you won't have anything because 0 times infinite, that's just 0. But now when you look at the second term right here, so you have minus. Now you first need to integrate it. So e raised to minus kx, so we'll evaluate it again. Minus kx, you already have a minus k below. So minus k times minus k, that becomes k square, and then 0 to infinity. Now, you have a minus outside, and here you add e raised to minus infinity is 0, whereas e raised to 0 is 1. Right? Did you understand what I said? E raised to minus infinity, because k times x, it would be infinity. We'll just substitute there, minus e raised to 0 by k square. So this becomes plus 1 by k square. So that was a big one that we just solved now. And here's how the formula goes for this one particular derivation if it's in product rule. So that was all in the lecture slides I gave you in brief. Now, if you have any doubts, you can just let me know. You can ping in the comment section, that also works. It's like I would hope that we always have an interactive session. I've been seeing that from the past 2 weeks, no one's joining. Someone was there in week 3, but later he or she left the meeting. So it would be good if it's an interactive session, we can also learn together and can solve problems. If not, then that becomes too one way, and for me, just solving, it would be like okay. So that's why it would be good if you people are also here able to answer it, and so that I can also know that whatever I'm saying, it's going through. Okay. So let's just take a 2-3 minute break, and then we can continue with the assignment question for this week. Okay. Okay, so I guess we can start now, and then like we have already spent some time. So I wanted few of you to join for this session because we did see that there were questions from assignment, but it's fine. You all can always go to the recordings and have a look at what we have been solving and how to solve that term. If not, you can join in the next session then. Okay. Now, the question is you want to evaluate the integral of this term. We just did something similar to it. It's 0 to infinity e raised to minus kx and dx. So you'll do it as e raised to minus kx. You have minus k here. Evaluate it from 0 to infinity. You can give it as e raised to minus infinity because, and then minus e raised to 0 is e raised to 0 here. And then you have a minus 1 by k here outside. So you get this as 0 and then this as 1 minus minus plus. So you have 1 by k. So your answer is this first one. Okay. Now second, a population of dividing cells starts with 200 cells. Number of cells in the population increases at a rate of this per day. What's the total number of cells after 3 days? Now, this is something dependent on time. Initially, it was 200, and then it is increasing at a rate. Now, we want after 3 days. So, from the first day, it's a day till 3 days, right? So, you have 200 plus 0 to 3, and times your kt is 20 t. Not t, but it's function of this, so that's dt. Okay, so this is dt. So you get as 200, and then now this is a constant, so it can come out easily. So you have 20, and then t comes, so that dt is t. So you'll get t from 3 to 0. Evaluating 3 from 3 to 0 is 3. You get this as 260. Okay, this type of sums are very easy to solve, and like it's better if you don't mess any of them. Okay. Now there's like area of healing wound. It A of T. This A of T. It changes the rate. Hence it is like rate changing, where T is time in days, such that we have T limits. Here K constant is being given. If A T equals to 1 is equals to this, what will be the area of the wound after 10 days? So after 10 days, they have asked us. Okay. Now, how do you do this? So you get it as dA or by dt. You do it as minus k by t. Right. Now, when you integrate on both sides, if you all remember, for if we differentiated log, no, but we didn't do a special session of log, but I have shared those notes in week three's or week two's folder. So you can go and check it there. I initially wanted to, but there was some times restrictions. So that's 1 by x. Okay. So if you have the other way, it will go the other way. Right. Such as if you can look over here. So now this dA integral is equals to minus k by t and dt. So this becomes minus k and this will become as log of t and then plus c, right? Something as this. Now they have told us at t equals to 1, it was 10 centimeter square. So at t equals to 1, probably it's just starting from it and that's its initial value there. So your c is nothing but 10 here, right? Now since you get c as 10, you have k as 4 minus 4 and you get log of this t that is equals to 1 that we are looking at. You get it as 10 centimeters. So this is, sorry. Yeah. So you want to evaluate it till 10 plus you have this as 10. Now this value they have given us, this is minus 4 times 2.3 and plus 10. So you get something as 0.8 there. Okay. Now you are measuring the growth rate of an organism in the exponential growth phase. Okay, so this itself tells you that this is something as exponential growth phase. So you have something as e raised to x here by adding different doses of particular drug in the growth medium. Assume that you want to mathematically compute how the growth of an organism varies with the concentration of the drug. Now, how this growth of an organism varies with the concentration of drug. So what it is dependent on, it's dependent on first that dose that you're adding and how the growth varies with the concentration of the drug. So of course it's a rate, a growth rate. So it's something with respect to time and the function that you're looking at, it's function of your concentration and time. Which of the mathematical functions expressed below assume n is the number of organism at a time t and concentration? Okay, so I'm measuring the growth rate there, and now uh, given you will be dependent on this one. So of course it's dependent on time, but then it's also dependent on the concentration. It varies with concentration here. So you add one for concentration. So see which one is similar. D, C, T. Of course, N is like number of cells that you have there. So number of organisms at a time. It won't. So double differentiating it doesn't mean it's partial. So this one doesn't work because you have two different terms here. At the time, it's function of two different terms. This. So automatically, this one becomes the first one. It's like you didn't have to compute anything. It was just as it is given to you. Okay. Now, if V is the volume measured in centimeter cube, D is the density in this, then what should be the units for integral of D V? Cut it, you get gram. So what you get is nothing but mass, right? So it would be gram, right? Yeah, that's gram. Okay. Now let G of t be the rate of growth. It increases with weight. Rate of increase in weight. Okay, so that's nothing but weight increase over time. That's your G of t for a child in units of kg per year. Okay, yeah, of course, that we know. Betty is in years. Now, in an experiment, we found the following data for the growth rate. Numerical integration of this has ranges of what? Okay, so we want to integrate it from 10 to 5. So, what will be the answers here? Okay, so for 10 to 5 years, we are looking here of the function. So, what will the function give you? The function will directly give you a difference in between these two values, but now it's saying has ranges of what to what. Okay. Hmm. So probably there are some rules applied here, but they haven't told you exactly how to solve for those rules. But let's say if you want to integrate it, every function with its own time, and that's a rate that you're looking at here. So it would be something as, and we have to solve from 5 to 10. Okay. For this, I guess you'll have to apply a rule that's called as trapezoidal rule. So you can skip this question. Without knowing the theory behind it, you won't be able to directly apply it though. So you'll first need to understand it, how it's going from there, else it would be difficult to understand in that case. Yes. Like there are formulas for it for starting terms, and then all inside term you directly add them. So for the first term, you take this term, add all of them, and then take your mean of them. So in this case, the answer is this one. But I'll suggest that first we revise this through and then only we solve it. Okay. Now, imagine some proteins in a single cell organism aggregating at a rate given as this, where this is their aggregation. We want to find an expression of R of t, assuming that at 0 there exists an aggregate of this. So for already they have given us value for C, and the C is equals to 10. Okay, so we just have to integrate it. 2 square root of t. Okay, so you can write it as integrated both sides, right? When you integrate, you get R is equals to, now you can write 2 and then this is half. You can write this t, this is 3 by 2 because you'll do 1 by 2 plus 1, right? By 3 times 2, right? 2 will come ahead plus c, and c they told us 10. So this becomes 4 by 3, and t3 by 2 plus 10. So that's the answer. Which one's the answer here? This one, I guess. Okay. So keep in mind the C is also very important there to add it. Okay. Now graphically find out the integral this. We'll have to find out the integral. Now, if you don't know how the function looks like, first just directly see if the function is even or odd. That we just learned. Okay. So first see if it's even or see if it's odd. So if it's even, first for even the condition is like this, right? And for odd, you have a minus sign there. Wait, what am I writing? Right, this is for odd. Now, when you're solving for even, get a minus sign here. So that's minus x and exponential of minus of x square. So minus sign will do nothing here. So that's even function. Whereas if you look at, oh, no, sorry. So you got a minus sign out there. So this f of x is in. So this function is nothing but an odd function. Now, odd function directly give you a value of 0. Right? Was it easy? Okay. Then we have something as imagine production and decay of a protein as a function of time as the conditions inside the cell fluctuate. Under some conditions, the protein will be produced, under some, it will decay. Let C of T with the change in concentration of the protein as a function of time. We only know that it's been given to you like this, where T is T by T, a dimensionless quantity made by dividing T by the oscillatory period of the protein. What is the net charge of protein given by this? Okay, so from here, for the ninth one, what do you see here? It's telling us that x plus pi is equals to minus of C of x, right? So it's giving us a minus quantity there. So now you remember, all students take care, and then you're just having a pi there. So in between these two functions, you'll only have either a sine or a cosine x. Now you evaluate the function at 0 to 2 pi. You evaluate a sine x. Evaluation for sine x is 0, right? Whereas if you do 0 to 2 pi for cos x, you have 0 pi 2 pi. No, 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 no. For cos x, you have 0 pi 2 pi. No, 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 no. We are writing this wrong. The graph is wrong, sorry. Cos 0 is 1. So cos is made like this, right? This is 0. Cos pi by 2 is 0, right? Because it goes the other way. This is pi by 2. Cos pi is minus 1. This cos pi minus 1. And what is sine pi? Cos pi. Cos pi is minus 1. Then what is sine pi? Sine pi is 0. Okay. And then this is 2 pi. Oh, no, no, no. Wait. And then this is 3 pi by 2. Then one more here. The cycle ends here. This is your 2 pi. Of course, it will go this way. So now you have 1, 2. This is minus solved. 1, 2. Of course, you have this one. Oh, sorry. Not that one. 2 pi ends here, right? And this one. So this is cancel, cancel, and cancel, cancel. So that's also 0. Right? So you get a 0 here. In both cases, the answer would be 0. Okay. Now, this kind of functions you just really need to imagine. Don't just think that, okay, every time a formula will help you. You'll have to know, you'll have to visualize how this graph also looks like. Now you have a question that imagine density of a microorganism given by a function as this. What's the net change in density? Hint, use the product of two functions here. Now the hint is, let's see if the hint is helpful to us. How do we use the product of two functions in this case? So this is 1. That's essentially 1. And then we want to evaluate the function at 1 from 1 to 2, right? So this is ln of t and that's 1. So it's fine. dt. ln t will give you what? Oh, okay, okay. Why they told us because we won't be able to solve it. Now the product of two functions, u and this dv by dx. How the formula stands as you evaluate the function itself from 1 to 2 and then now what would the function in this case? dt, okay, this would be t is equals to 1. So your v would be equals to t, right? Okay, and u as ln t. And then you have a minus sign. And then what's the formula? V first, U first. There's it's U first. V and du by dt times dt. Most likely. I'm not sure of it. Let's just check it. It's like remembering the formulas at one go, it's too difficult. Did we write it correctly? Yeah, V and this. And you have a limit of 1 to 2. Now you have U as ln t times you have t, you evaluate it at 1 to 2, minus, we want to write it a v here, that's t, times du by dt. Now you know for ln x, it is 1 by x. So that's 1 by t, 1 by t, dt, 1 by 2. Oi, ha, yeah, we wrote it correctly. Now this one, you have ln 2 times 2. So this 2 is nothing but a constant term, will go outside, minus, we'll have 1 times ln 1. So we all know that log 1 is 0. It should always be higher than that, right? Minus, this all cancels, so it would be t. So you evaluate t at 1 to 2. So this would be just 1, right? And this is nothing but 2 ln 2 because this is 0. So you have 2 ln 2 minus 1. This is your answer. Okay. So I hope that's clear, solves your doubt. If you have any further question, you can always let me know and I'll attach the figures here. I've solved all questions except this trapezoidal rule. So if you want, you can directly Google it out or else I'll explain it in the next session. So it's just that if you know the theory behind it, you'll find it easier to solve it. For now, you can just leave it as it is or else you'll get too much confused into it. Uh, or else other ways you can try is like plot this in Excel, okay, and find the area under the curve. That way you can also solve it. If you don't know the formula for it, just plot it in Excel how it goes, like make it as t and make this as g of t and find the area under the curve. Okay, that's one approach how you can do. I told you the answer for this one, that's 3 to 5, but nevertheless, we'll solve it in next session. Okay, so if you have any further questions or queries, you can mail me, you can add comments on the YouTube videos, or else you can join in the next session. Okay, so we'll see you. Bye bye. Thank you.